40 years ago. 40 years ago when I gave a talk at Cornell. It was on an airplane where the pilot turned around and said, "Anybody want to sit in the front seat?" So there were like six of us on the plane.
Yes, well, it did get better for a while, but maybe that's the future out there. Who knows?
Yeah. And what I did do is take the bus when I left. I took the bus to Syracuse and then the train back to Boston.
Yeah,
So I was a train fan even then.
there you go. Yeah.
Okay, well, it's 9 o'clock. We've got a smaller than usual gathering here. I'm not quite sure why, but usually we get about 2 dozen or so. People still coming in, so we'll give them a moment. It's 9 o'clock in the morning where I am in Tucson, and 6 in the evening where Fernando is, if I'm reading
Yes,
that correctly.
that's right.
I have on my desk two clocks. One is set to Eastern time and the other is set to Rome time. So I don't have to try to add 3 or 9 in my head because that's far too difficult for me. Um, since we're waiting for one or two more people, I'll tell the story some of you know. When I was teaching at Lafayette College and deciding there must be more to my life, I did this calculation. I said, I had just broken up with somebody. If I met the perfect woman, I'd be 40 by the time we started to have family. Those kids would be teenagers when I was 65. That's way too old to be raising teenagers. So I should look into plan B, namely joining the Jesuits. After I joined the Jesuits and I told this story, one of them pointed out that 40 plus 15 is 55,
Right.
not 65. So I joined the Jesuits because I don't know how to add.
And have never regretted it since.
No, not at all.
I am
So there's,
absolutely certain that is not the only reason.
but for the kids in Dave Wells' classroom, you see, arithmetic does matter. Don't think it doesn't.
And mistakes can lead to happy endings sometimes.
This is true. We learn from our mistakes.
Right.
Well, welcome everybody. The way we do this is, for those of you who are new to this, we'll start by going around the screen here. Everybody tell me where you are and what the weather's like and if you saw anything interesting in the sky recently. So I'll start with you, Bob. Where are you? What's the weather?
I'm in a northern Burba, Detroit, Clinton Township, Michigan. It is clear as a bell outside, which is wonderful because it is statewide astronomy night today in Michigan. There are events happening all over the state. And I haven't seen anything because it has been cloudy forever until today. So,
Because it's Michigan.
yep.
Jonathan.
Good morning, everyone. I'm Jonathan Lunine. For those of you who don't know me, I'm a planetary scientist, a chief scientist at JPL, and a professor at Caltech. And so this morning I slept in because I got back really late last night on a flight. But the Friday morning, so that would be yesterday morning, yes, I did see a brilliant Venus in the morning sky as I was walking on campus, and the air was exceptionally clear and dry.
All right. Margaret Ann.
Working on finding my mouse. Well, I'm not too far from Bob, and I also have not seen a heck of a lot in the sky.
So you're just outside of Ann Arbor?
That's correct. That's correct. I'm
Right.
very close to Ann Arbor.
Okay. David, tell us about where you are and what's the sky like there, and have you or your kids seen anything?
We're in Knoxville, Tennessee, and we've got about 30 or 40 students from St. John Newman School and Sacred Heart Cathedral School here in Knoxville, along with about 10 or 15 Civil Air Patrol cadets. And it's kind of cloudy. It's been kind of cloudy, but we're hoping the skies will clear this afternoon so we can do some solar observation. We've got Coronado Solar Telescope set up, ready to go as soon as the clouds cooperate.
What's the temperature there?
I think it's in the 50s right now, 48. It's a little chilly. Call it dogwood winter.
Okay.
So it's really pretty right now, but it's a little chilly.
Okay, Larry.
This is Larry Lebowski. I'm in Tucson, Arizona, a little bit north of where Guy is right now. It was 101 yesterday, which beat the record by 7 days, 8 days for the earliest 100-degree day in Tucson. I've been doing too many nights at schools or evenings at schools. Last thing I remember seeing besides the moon is moon near Jupiter a couple of nights ago.
And where are you off to tomorrow?
I am going to Mount Graham tomorrow to the Vatican telescope to observe asteroids.
Excellent. Jim, where are you?
Good morning. Jim Wren here from Anthem, Arizona, just north of Phoenix. And it's going to be 100 degrees. Like Larry said, it's early hundreds for Arizona a little bit, and it's going to be clear.
Okay. Phil, where are you?
I'm in New Bern, and the weather here right now is in the mid-50s.
We missed the beginning, so start again.
Good morning. I'm in eastern North Carolina, New Bern. Weather here is cloudy, mid-50s. But I had a great opportunity a few weeks ago, maybe 3 weeks ago, driving back from Ohio in the early morning before sunrise. I got to view Mercury and the crescent moon, and then followed that by a beautiful sunrise. So it made the long drive more pleasurable.
Okay, Clark.
Well, I'm about 5 meters from Margaret. It's 11 degrees outside, Celsius, 51 Fahrenheit, clear sky. Last night, the moon was absolutely gorgeous while I was out driving. And just a comment about Knoxville, the last time Margaret and I were there, it was snowing. We saw 6 inches on our way to Georgia that day.
Ouch. Fernando.
Yes, hi, good afternoon from near Munich, Germany. Wonderful weather here, nice afternoon, which is the last one, I'm afraid, in a series of several days. And one interesting thing in the sky is that in the morning, 2 days ago, I saw T Corona Borealis with my small telescope, which is this star that is expected to be a nova any of these days. So what I can say is that it doesn't become a nova yet.
Okay.
So,
Any of these days for months now.
About a year now.
any day. Let's be optimistic.
Right. Maureen.
Good morning from Manhattan, where it is cold and damp and dank and raining. And I saw one interesting sight this month. It wasn't exactly in the sky. It was actually in an office building, and it was you, Brother Guy. It was nice to see you.
Hey, it's as bright a star as you'll wind up. Probably as bright a star as you can see from Manhattan. Gary.
Hi, I'm in Milwaukee, Wisconsin. It's in the 40s here and clear today. I haven't seen anything interesting for this group probably, but my granddaughter, 3.5 years old, had learned the names of the planets. And so this spring we started going outside so she could actually see the planets.
Fabulous. Katie.
Hi. Well, I'm in Pasadena with Jonathan. We had coffee a couple of weeks ago over at Caltech. And it's yesterday it was in the mid 80s. Right now it's only 62. And today we're opening up for the season Mount Wilson Observatory. So after this, I'll head up there and try to make sure everything's running well up there. But it should be a nice day, maybe even 70 degrees up there. So
fabulous.
How do we find the schedule of your concerts?
When we publish them.
Got it. Okay. Thank you.
No, there were a few changes this week and everything's coming out. It was published yesterday, but in a newsletter to members, and then it'll get out in the next couple of days, by Monday probably.
Okay. Thanks.
Yeah. Good. Hope to see you up there.
This picture, which is in my new book, everybody should have at least 2 copies of it by now. This was taken from Mount Wilson when Katie brought me up there about 1.5 years ago.
Right. That's from overlooking LA from the monastery. I recognize it. Yeah. Yeah. That's great. You'll have to come back.
I need to. It was wonderful up there.
Right.
Rob.
Yeah, I am in Flagstaff doing some outreach this weekend. So I am it's 62 degrees here, and um, let's see. I got up a little early a few days ago, and I saw the summer triangle about 5 in the morning. I hadn't seen that in a while. It's not up in the evening sky this time of year, so it was kind of a welcome sight to see that again.
Jeff.
Well, but uh, but uh, but anyway, I'm here in Manorville, New York, and it's 39 degrees, but they said it feels like 28, so nasty weather. But I haven't seen anything lately because it's been so cloudy and rainy. The weather around here is horrible, But aside from that, everything's okay. So we're hanging in there.
James.
I'm from Southington, Connecticut. It's 36 degrees, and like many that I'm hearing, it's very cloudy, dank, and rainy. It should be drying up, but not the clouds going away. And it's been cloudy like this for the last couple of weeks on and off, so it's been difficult to see anything in the sky.
And Justin.
Watertown, Connecticut. We had 2 inches of snow overnight, so
no.
It warms up. And James, only 30 minutes from you. Looking for the pink moon tomorrow night.
Which of course reminds me of the wonderful Nick Drake album called Pink Moon. I'll throw in a little bit of astronomy on my own. The past 2 weekends, I've given retreats at retreat centers, basically, going out and looking at the stars and spirituality, that sort of thing. And in both cases, we wanted to have people go out and look at the sky at least one night. In both cases, it was cloudy all weekend, but the night we went out, there were sucker holes and we were able to actually see a few stars. You could see Jupiter through the thin clouds. And there I am trying to point out all the stars with, it's very vague and you can only see the brightest ones. And I'm getting about half of them right as the sky thins out and I realize can you see that was kind of orangish looking? And then, no, sorry, that was Rigel. That's not orangish looking. The orange one is over there. But the most embarrassing moment was 2 weeks ago in Atlanta, and suddenly there's a hole right overhead. And somebody looks up and says, "What are those 3 bright stars in a triangle?" And I'm going, there aren't 3 bright stars in a triangle. And look up, and sure enough, there's 3 stars of equal brightness in a triangle. And somebody pulls out their app and points out, one of them is Mars, and the other 2 are Castor and Pollux. So it was showing that, guy making a fool of himself yet again. At this point, we usually have Paul Gabor telling us the latest in the telescope, except he's at the telescope. And I'll just report that he was up there. The trouble report said that the telescope's been behaving itself very nicely. He was up there to look at a star where an exoplanet transit had been reported, but they don't have enough measurements and enough timeline to know the period of the planet, whether it's a shorter period or a longer period. And one of the multiples would have been last night. So they're looking at the star to see a transit. It's a faint star. It'd be a faint result. You could not have seen it in a telescope smaller than ours, and you couldn't have gotten time to look for it in a telescope bigger than ours. So it's a perfect example of what the VAT is really designed to do well. And they got clear enough weather that they said they at least got the clear weather and took the data, but it's going to take a little bit of reducing the data to see if they really saw what they were looking for. So with that, I'm happy now. And because this is being recorded for a podcast, I'll start here as if I'm starting the podcast. It's my pleasure to welcome to this group Jonathan Lunine, Dr. Jonathan Lunine, who's been a friend and a rival and enemy and all sorts of marvelous things going back to when we were both in grad school. He's a bit younger than me, but not too much. So I saw him coming up behind me, and as Satchel Paige once says, don't look back, they might be gaining. He certainly gained. Jonathan, welcome.
Glad to be here, Guy. Thank you.
Tell us a little bit about yourself, what you do now, and basically what you've done. But start with what you're doing now.
Okay. I am the chief scientist at JPL, the Jet Propulsion Laboratory, and I'll get back to what that is in a minute. I'm also a professor at Caltech, professor of planetary science. I'm a planetary scientist, and I also do some astronomy, not observational astronomy, though. I've broken voltmeters and shocked my lab partner in college enough to know that I need to stay with the computer and all that stuff. But NASA's Jet Propulsion Laboratory is one of the NASA facilities around the country, and it's the one that is the center for planetary exploration, robotic planetary exploration. It's actually not a NASA civil service center. We're not government employees, we're Caltech employees, but all of the property is owned by the federal government. And so we operate it under contract. And JPL started out as a little experimental rocket facility and jet-assisted, rocket-assisted takeoff facility in the 1930s and 40s, and evolved to become the place where one-ton rovers are landed on the surface of Mars and driven around all over the place to find evidence for life and to figure out how Mars went from being very Earth-like to the thing we see today, which is pretty uninhabitable. So, so what do I do there? Well, I'm the chief scientist, which means that I have no authority. I'm not a line manager. I do, however, give out money, which is a really nice thing to do, to scientists and technologists who have cool ideas and want to seed their ideas with a little bit of research before they go out to try to get grants from NASA or elsewhere, or before these things get incorporated in spacecraft missions. So that's one thing that my office does. I have about 10 people. The more exciting thing that I do, though, is I'm the face of science. I'm supposed to advocate for science at the laboratory and around the country. Our lab director, Lori Leschen, is a scientist, but by and large, JPL is an engineering organization. About 80% of the people who work there are either engineers or administrators, and only 20% are scientists. But those scientists are crucial because we provide the, if you will, excuse my French, the raison d'etre for what's done. And while there are lots of scientists around the country who work with JPL, having scientists there day to day, working shoulder to shoulder with the engineers on these missions is crucially important to make them successful. And so I'm the guy, sorry guy, who pushes people along and encourages their science and tries to find ways to incorporate more science in these missions. And I enjoy doing what I do. And then on Fridays, I go and teach at Caltech.
Well, this is not your first time at Caltech, of course. You were a grad student there, right?
I was a grad student there from 1980 to 84. And when I started working on models of the Galilean moons, my thesis advisor, David Stevenson, said, you need to read this paper. And he handed me a paper. Of course, back then there was no electronics. These were paper papers by Consolmagno and Lewis, having to do with formation and evolution of the Galilean moons, and especially of Europa, but the other ones as well. And so, you know, I'm an innocent grad student. I looked at this paper and I thought, Consolmagno, first author. I imagined this distinguished scientist with a very gray beard. Then when I actually met Guy, I think a couple of years later at a Saturn conference in Tucson, I thought, is this his son? No. This is Guy Consolmagno. And so, you know, I didn't even think that he might be a grad student or a postdoc or something else. But it turns out actually that this was simply prescience, because here we are years later, and I am talking with my dear friend who indeed has a very, let's see, gray and white beard, as do I. So yes, I was there at Caltech from 80 to 84, started working on things that Guy had worked on for several years before that, and have always, I have to say, enjoyed our collaborations, enjoyed our competitions. I think it's been a real grace to have had a career next to and slightly behind of Guy Consolmagno.
Well, I was certainly one who was hearing about this hot grad student that Dave Stevenson had, and I better watch out because he's catching up on me. So there was a certain uh, trepidation when I, was beginning to see the work you were doing. But I also have to claim, much as you may have zapped your lab partners, you probably have never broken as many telescope filters as I have. The one time I dropped the filter and it went down a metal staircase, a filter wheel,
Wow.
so that every filter in the filter wheel wound up getting shattered.
You win.
Probably the only competition I'll win with you. But tell us how you got into planetary science in the first place. What made you interested and what did you do about it?
I was always interested in astronomy. I grew up in New York City, where, as we've just learned, it's difficult to see the skies, but we live pretty close to the Hayden Planetarium. And so when I could get my mother or cousin to take me there, it was a wonderful experience. And I knew I wanted to be an astronomer of some kind. And then when I was in high school, a book came out called The Cosmic Connection: An Extraterrestrial Perspective by a Cornell professor named Carl Sagan, who at the time wasn't that famous. This was 6 years before his Cosmos TV series. But I read about the book in Sky and Telescope, I think, and I bought it and I just fell in love with the book. In fact, so much so that my mother, trying to stem this never-ending reading out loud of passage after passage, said, "Why don't you write to Professor Sagan?" And after a little bit of encouragement, I did. And so for those of you young people out there, don't be afraid to write to scientists or others that you admire, because many of them will do what Carl did, which was write a 2-page letter back on how to become an astronomer, enclosed a reprint on the Mariner 9 observations of Phobos and Deimos. That was the first Mars orbiter that was operating there at the time, first spacecraft to orbit Mars. And that kind of, it launched my interest in planetary science and robotic exploration of the solar system. And that was reinforced about 5 years later as a junior at the University of Rochester, getting my copy of Sky and Telescope for March of 1979. And there on the front cover was the Voyager of Far Encounter picture, probably from January, taken by Voyager 1 of Jupiter. And it was so much sharper than the telescopic images you could get at the time that I said, that's what I want to do. And so I applied to graduate programs that had planetary science degrees.
There weren't that many back then.
No, there weren't. It was very simple to just find the ones. And, I think I applied to maybe 6 schools and that was it. So.
When Carl Sagan was at Cornell, he had a chair, a named chair, right?
Yeah, it was the David Duncan chair, David Duncan Professor of Astronomy is what he was called.
And who's a later holder of that chair?
Well, okay, so Yerevan Terzian was the next one, and then I was wooed to Cornell from the University of Arizona, and actually was not part of the wooing, but they were very kind enough, and Yerevan was kind enough to hand over that chair, and I became the David C. Duncan Professor. By that point, it was called the David C. Duncan Professor in the Physical Sciences. Now, you might think, by the way, that that was a more illustrious title because it was all of the physical sciences, but this was actually just a dean's trick. By doing that, the dean could hand that chair over to someone in physics or chemistry or astronomy, so it became a more lucrative kind of carrot, I suppose, or prize for him. But anyway, I was very humbled and really I kind of moved that this happened, and that the person who was really so much an inspiration to me in getting me started in my career, that I would have the chair that he held, and in which he did so much. I mean, his courses, there were students pouring out into the hallways who couldn't get into the room when Carl would lecture. And I was certainly a pale substitute for that, but I was very, very moved to have that chair.
Did you get to meet him? Did you work with him?
I
did. He remember you?
Oh gosh, he remembered me. He remembered me because after our correspondence ended, a few years after that. I went to college, then went to Caltech, then showed up at the University of Arizona, first as a postdoc and then on the faculty. Unbeknownst to me, my mother, who was never shy about writing to people, wrote to Carl Sagan and said, I don't know if you know this, but the young boy that you wrote to has become a professor at the University of Arizona, and it's all because of you, and so on. And it turned out that he wrote back to her, and he said, "Of course, I know Jonathan. I haven't forgotten him. We're even thinking of trying to get him to Cornell." And my mother showed me that letter about a year or so after she had written it. So yes, Carl remembered, and then we ended up working together on the Cassini mission to Saturn. He died in 1996, a year before it was launched, so he never saw the results of it. But also, I'll just tell this very brief story. In 1983, when I was a graduate student working at Caltech for Dave Stevenson, we had come up with this idea along with another professor, Yuk Young, that the surface of Saturn's moon Titan might be covered with an ocean of methane and ethane. This was to try to explain the Voyager data, that there was a lot of methane in Titan's atmosphere, but not enough to be saturated. And so there had to be something to keep the vapor pressure of the methane reduced, or it was kind of a coincidence. Well, it turns out to be more of a coincidence, or just a particular state at a given point in time, because there is no ocean, but there are seas of methane and ethane. But I gave this talk at Cornell, and it was actually not what was written in the abstract, because we had not come up with this idea at the time I wrote the abstract for this conference. It was a small conference held at Cornell University, run by Joe Burns, another planetary scientist who passed away sadly late last year. And so this talk that I was giving was on a subject that had not been advertised. And so I get up in this room full of people at Cornell, having flown out from California. I give my talk on the ethane ocean on Titan. And the talk is over, and the session chair says, "Are there any questions?" And somebody raises his hand and says, "Would solids float or sink, organic solids float or sink in the ethane-methane ocean?" Remember, Titan's very cold. That's why the methane and ethane are liquid. It's minus 290 Fahrenheit, 94 Kelvin. So I knew the answer to this question, that most organic solids would actually sink. And I started to open my mouth, and from the back of the room comes this unmistakable voice from the Cosmos series, which I cannot imitate. "I know the answer." And the room was dark, up comes a figure and begins to move to the front of the room, and it's Carl Sagan. And he's holding a transparency. Those of you who are old enough remember that we didn't have PowerPoint slides. We had these transparent acetate things that you wrote on, and you place them on these overhead projectors. And Carl has this transparency meticulously written out densities, a table of densities of organic solids, which he places on the overhead projector, which a moment ago it had my talk, and proceeds to give a Carl Sagan dissertation on the density of organic solids. Now, how does he know that that was the talk I was going to give? Someone must have tipped him off, and it could only have been my thesis advisor, because this was an evening session, and before the talk, Dave and Peter Girash, who was there, took me out to dinner and said, "You need to have a beer first." And I think it was to prepare me for the onslaught of Carl Sagan.
Fabulous. I'll tell a Carl Sagan story from that Saturn meeting when we first met here in Tucson. Of course, in those days, there were slide projectors, and you would get a graduate student to run the projector, next slide, and he'd push the button, and the next slide would drop in. And Carl Sagan came in, and one of the first times he gave a talk where he was describing the chemicals that he thought might be found in these organic clouds. And he described them as long chains of organic, and I can remember him pulling his hands apart to show the long chains. And he says, "I'm using a word for these from the Greek. They're called tholins." And all of the grad students at Arizona start breaking out laughing because the kid running the slide projector happened to have the name Dave Tholen, spelled differently, but sounding the same. So I think it was a reaction that Carl was not prepared for. What part of what this shows, of course, is that being a scientist is not just a thing, but it's a personal choice. It's running into a small group of people. There's probably more professional football players than there are professional planetary scientists. And we all know each other, and we all have these wonderful stories about each other. What was your connection to the Vatican Observatory, and how did you first become part of what we're doing?
So the first Jesuit that I think I ever met might have been you, because, and it was around the same time, but I showed up at a DPS meeting and you showed up at a DPS meeting. And of course, we had been sort of loosely.
This is Division for Planetary Sciences.
Yeah, I'm sorry. I should not use, I've committed the great sin of using an acronym I have not defined, the Division for Planetary Science, which is a professional society of planetary scientists. They hold an annual meeting. And Guy and I had been sort of loosely collaborating when you went back to Lafayette College. And anyway, I run into you at the meeting, and we all have name badges with our affiliations. Mine said Jonathan Lunine, Lunar and Planetary Lab. And yours said Guy Consolmagno, SJ. And I thought, what does an SJ mean? And so I don't know what year that would have been, but it
94 maybe?
94. So actually that was after then, because when I first came to the University of Arizona, I was invited to a dinner with the Jesuit astronomers, and Martin McCarthy was still there, I believe.
Maybe it was 91 and 92. Maybe it was when I was still a novice.
It was 91 or 92.
Okay,
so anyway,
sure.
Everyone's loving to hear these attempts to figure out the chronology. But the bottom line is it was at the University of Arizona. Lovely dinner. It was some sort of event. And I was not a Catholic at the time. I was raised Jewish. I became a convert. I converted to Catholicism in 2007. But my wife, Cynthia, and I came to know George Coyne over time, being at the University of Arizona. And we had various different interactions. We actually invited him out. He loved to, of course, hike, and we did a barbecue in the woods down near we lived.
George, of course, was the director of the Vatican Observatory and the fellow who had set up our house and telescope in Tucson.
Yes, Father George Coyne, who was a remarkable astronomer, a wonderful human being, award winner. He won the Van Biesbrock Award, I believe, of the AAS. You're a winner of the Carl Sagan Medal of the DPS, AAS, American Astronomical Society, which is the parent organization. So I'm sorry for this mishmash of a story, but anyway, I really came to know the Vatican astronomers when I, together with Woody Sullivan, proposed a Vatican summer school on astrobiology. And I think the first time we proposed it, it was declined by the Vatican astronomers. And then the second time it was approved. And so was the start of my sabbatical in Rome in 2005. And my wife, our son Joseph, and I spent 4 weeks up in Castel Gandolfo helping out with the summer school. And it was then that I really came to know, I mean, I knew Guy very, very well. I had known George back in Tucson, but I didn't know the other Jesuits very, very well. And it was through that experience that I came to know and really deeply admire them, and particularly because one of my favorite subjects that I talk about a lot, in fact, I talked about it last night at Berkeley, is science and faith and how they interact with each other. And for me, and I apologize for embarrassing you, but the way that the Jesuit astronomers live their lives of science and faith in a completely unself-conscious, harmonious way made a huge impression on me, and was an influence in what I decided to do with my life. And so that all started back in Tucson.
And you also wound up spending at least 6 months living with us, as I recall, a sabbatical time.
Thanks to you. So this was the start of what would have been a 3-year leave of absence in Rome, teaching at Tor Vergata, the second Rome university. I'd applied for a government program. My department chair back at department head back in Tucson, who Guy knew really well. He's passed away now. Mike Drake was kind enough to give me a 3-year leave. I think because he found out from the dean that he could use my salary to pay for various things around the lab during that time. And but my wife and son didn't want to leave. He wanted to finish middle school first. This was 2009. And so there was about a 6-month period where they were still in Tucson. And so Guy very, very generously offered me a guest apartment in what was then the new headquarters of the Vatican Observatory group on the other side of the Vatican Gardens from Castel Gandolfo on the Albano side. And I really enjoyed that. I did a little commuting, well, much as you do, did commuting back and forth from Tucson there to Albano. But it was a lovely time, and it's very well set up. It's private enough that I don't bother them, but when they want to invite me for dinner or to come to mass, I'm right there, just a stone's throw away. So it was perfect, and it was during that time that you introduced me to Georges Lemaitre by loaning me the book, The Day Without a Yesterday. And that became a passion of mine, and I've given many, many talks on Lemaitre. That story has evolved since that time, but you were the one guy who got me started on that.
And the author of that book I met through the science fiction world. He's also a science fiction fan, lives in Boston.
Yep.
So there's a connection. He's also very embarrassed. The most important story in that book took place at a 1957 meeting at the Pontifical Academy of Science, which by a typo is called 1947 in the book. So be sure you cross that out and add a 5 there.
Pick that. I will actually do that when we're done here. And so is that the photograph that's in the Vatican Observatory Museum?
Yes.
That's an amazing photograph. Some remarkable scientists all together.
Sort of the who's who of astronomy at those days gathered at the Vatican to debate the population of stars and why some stars are different from others, but the implications of the populations of stars basically showed the world that the universe was changing over time. It wasn't in a steady state. And that was, of course, one of the great supports for the idea that we now call the Big Bang.
Yeah.
But that's pretty far away from what you and I do. And you talked about Europa and the icy moons. That's the place where our paths first intersected. So I've got a question down here from one of the students, Oscar, who asks, do you think there's life on Europa underneath the ice? Can you talk about that theory and what you think the current status is?
I'd be happy to. So if I were a real professional chief scientist, at this point, I would switch the screen to a launch video of Europa Clipper, and we'd all be impressed, but I don't have that technical capability. So let's just imagine that happened. The answer to your question is I don't know. I don't know if there's life in the ocean of Europa. But what I do know is that we have a good chance of finding out the answer to that at some point, which is what's really exciting to me. So Europa is the second Galilean moon of Jupiter. And sorry, my computer complained to me there, but we're good. The second Galilean moon out first, there's Io, there's Europa, there's Ganymede, there's Callisto. And Europa has this very shiny, bright, icy surface, which is crisscrossed with fractures, has some orange stains on it, maybe from Io, maybe from its interior. But what the Galileo orbiter found, the orbiter that JPL built, named after Galileo Galilei, what it found in the late 1990s is that there's a liquid water ocean, probably salty, underneath this icy crust. And by the way, Europa is about the size of the Earth's moon, and it's mostly rock. In fact, if you stripped all the ice away, the rocky part that's left behind would be only a little bit smaller than the Earth's moon. So think of something the size of the moon covered with this bright, shiny coating, and a liquid water ocean in between the ice and the rocks. So the other exciting thing about Europa is that it's bathed in this radiation field from Jupiter. Particles get charged up, they get accelerated by the field, and they slam into the surface. And for a long time, people thought, well, that's terrible for life. But it turns out that some pretty clever people, not me, Kevin Hand and some others, thought through the fact that that radiation makes compounds that have a lot of oxygen in them, peroxides, for example. And if that material gets down below the ice crust into the ocean, then you have this oxidizing region in the upper part of the ocean. The water that's interacting with the rock makes that kind of reducing, produces hydrogen-rich compounds. And those two things together provide energy. The other thing that Galileo found for us, because it found an ocean and measured the gravity field of Europa, is we know it's a huge ocean. It's at least the volume of the Earth's ocean, maybe twice the volume of the Earth's ocean. How does it exist out in the cold outer solar system? Well, Guy was actually probably the first person in a scientific paper to postulate and think about how heating might happen, the decay of radioactive elements and so forth. We also know from the time of Voyager 1 that tidal heating is important too, the squeezing and pulling by Jupiter's gravity field. So those maintain this ocean. So liquid water, salts, energy source. What we don't know is whether there are organic molecules, carbon-bearing molecules. That's the stuff that we're made of. We don't know if there's phosphorus, an essential element for life. There are a lot of things we don't know that are important in understanding whether that ocean could sustain life and could have been the cradle for life, a unique life form. And so that's why my answer to your question is I don't know, but it's very promising. Europa Clipper, which is the next mission going there, it's on its way now, it was launched in October, will make 50 flybys of Europa. It will orbit Jupiter, fly by Europa rather than orbit it, so it doesn't get too much radiation dosage. And it has the kind of instruments that will tell us whether that ocean is or is not capable of sustaining life, and whether pieces of that ocean are actually coming out onto the surface and being deposited there. We have some evidence of that from Hubble Space Telescope and James Webb Space Telescope, some of which was work done by a former postdoc of mine at Cornell. So the next step after Europa Clipper, if things look good for the ocean being able to support life, is to go back, land in places where there's ocean material that's been deposited on the surface, and see if there are biologically produced compounds there. So this is a long process.
I do have to, since we have a few Europeans on this call, we should also do a shout out to the JUICE mission.
Yes, I was about to do that, but you shouted out.
Well, you probably know the details better than I. The Europeans also have a mission, which is JUICE, which stands for Jupiter something something icy something.
Icy Moon, Jupiter Icy Moon Explorer.
Okay.
A selective use of letters for the acronym.
Okay. And I know it launched earlier. Was it going to get there earlier? What is its science going to do compared to Europa
Yeah, so
Clipper?
JUICE is very exciting too, and I'm actually on both missions. I'm on the near-infrared spectrometer and the gravity science experiment for Clipper, and I'm on the gravity science experiment for JUICE. So JUICE we'll get there later. It'll get there a year later. It's taking a more leisurely tour of the solar system to get there. But it will mostly look at Ganymede and Callisto. It will, let me just hold on here. My son is texting, do not disturb on. Okay, good. It will mostly look at Ganymede and Callisto. In fact, it will orbit Ganymede, but it will do a couple of flybys of Europa. And it actually has a more precise gravity science experiment. You measure the mass distribution, the gravity field of these moons by repeatedly flying close to them and seeing how their gravity changes the velocity of the spacecraft. And that's done by precisely measuring the change in the frequency of the radio signal coming from the spacecraft. So they're complementary to each other. They're complementary in focusing on different moons, Clipper on Europa, JUICE on Ganymede and Callisto, and they're complementary in the couple of flybys that JUICE will make of Europa, where it will be possible to compare the results from the two different sets of instruments.
One thing I love to point out because it's so marvelously esoteric, the fact that you've got an ocean that is probably salty. I mean, you've got water that's in contact with rocks that can produce ions that make, sodium and chloride and other kinds of salts. That's important because Jupiter itself has a big magnetic field. If you have a conductor, a metal or a bit of salt water moving through the magnetic field, that sets up an electric current in that ocean, which then affects the magnetic field, and that can be measured by the flying spacecraft. And that's how the Galileo probe saw, there's evidence of a salty ocean there. So
Exactly.
it's a long chain of esoteric ideas that somebody had to sit down and think through. And very, very clever. And I'm blanking on the name. Who's the woman at UCLA who
Margie
actually
Kibbleson, who is 94.
Okay,
And,
yes, thank you.
and I have to give her a shout out because she also, so Europa Clipper has a magnetometer. It's going to do more precise measurements to get us the salt content of that ocean in just the same way that Guy talked about, the same technique. And she has just stepped down from being the PI of that instrument. I think
Principal investigator.
Principal investigator. I did it again. Two fouls. All right, third foul and I'm out. Yes, I at the age of 93, God bless her, she was the principal investigator of an instrument on a major mission of NASA, and she was the principal investigator, as Guy said, on the magnetometer that discovered the ocean underneath the surface of Europa.
Okay, is there any place else that you think is interesting to look at among the icy moons for evidence of this water?
Really interesting, lots of places. We now think of the icy moons in the outer solar system that have liquid water oceans or are suspected to have liquid water oceans under their interiors. We call them ocean worlds, and we, being the planetary science community that's more or less accepted this designation. Ganymede and Callisto in that same Jupiter system, there's evidence not quite as strong, but pretty good for oceans under their icy surfaces. Saturn's moon Titan, which has these seas of methane and ethane, from the Cassini spacecraft, evidence of a liquid water ocean deep within its surface. But it's Enceladus, this tiny moon of Saturn, only 500 kilometers, 300 miles across, which also has a liquid water ocean. It's spewing that material out from the South Pole.
You can actually see the water coming out.
Actually see it coming out. Cassini imaged this. It did a high phase angle looking the sun. There's Cassini, Enceladus, and then the sun. So the sunlight shining through this plume was what discovered it, how Cassini discovered it. And Cassini carried what were called mass spectrometers, devices to measure the composition of the material directly by ingesting it and sensing it. And Cassini made, I believe, a dozen fly-throughs of that plume of material and discovered salty water, organic molecules, phosphorus, phosphate compounds, silica compounds indicating the water reacting with the rocks. So that ocean, in that tiny moon, that ocean is only about the volume of Lake Superior, so it's small. But that appears to have all the ingredients needed to sustain life. And that's another place to go back to see if maybe life got a toehold there and exists today.
Okay. Among the questions the students had sent, you've already answered the next one, which was Jack Price asking if you had information on the next mission. Well, you've just given us that. But another question that comes up, this one from Iker Carcano, do you think that with all these chemicals you're describing, there could be resources on the other planets that can maybe help us develop new technologies?
So first and foremost, robotic planetary exploration itself is an excellent way to develop new technologies. The rovers that are on Mars today, Curiosity and Perseverance, look identical. They have different instruments, they look identical, but one arrived in 2012, the other in 2021. They're both built by JPL. The two of them could not be more different in terms of the automation that they have. Curiosity had a large landing ellipse, large error in landing. It didn't have any intelligence to navigate to its landing site. Perseverance did. Perseverance has a fast drive mode, which allows it to avoid obstacles. Curiosity does not. And so just in the space of a decade, these advances in automation were driven by the need to go to more challenging places on Mars. And that's going to be true with missions to the outer solar system. As exciting as it is to send humans out into the cosmos, robotic exploration can be done more cheaply, doesn't endanger human lives. I think in the long term, humans and robots are going to be working together, but right now it's robots that are exploring the entire solar system and generating that new technology, particularly in areas like automation and artificial intelligence.
So I come to the last question, which is my favorite of the questions that the students submitted. Before I get there, are there any questions from anyone else on the meetup? Feel free to type them into the chat or raise your hand, because I want to end with this one question, which I think is the best of the bunch. So if anyone else has a burning question they want to ask first, now is your chance.
And I promise to answer in a pithier fashion if you type your questions in.
All right, then. I will come to this final, just beautifully question from Marty Boder. Is there something you've seen, something you've studied, a conversation you've had with a colleague that made you say, in this, I see the face of God?
Wow, that's an impressive question. So let me first say that I see the face of God in everything. Not only the universe, the things that I study, but in every person. Of course, every person is the face of Christ, and it's taken me decades to really come to learn that. I'm a slow learner. It takes me a while to kind of get things, and it took me decades to decide that I really was a Christian and a Catholic Christian, even though I had hints of that when I was a teenager. But it's also taken me a long time to look at people's faces and see the face of God in those faces, not because it's not there, but because I have blinders on, and having those blinders come down has been really a grace. But when you look at the universe, when you look at this incredible mixture of order, beauty, and what looks like chaos, there's an intelligence behind that. That chaos that we see is not complete lawless chaos. It's chaos that's guided by the physical laws of the universe. It's guided by the way matter and energy interact with each other. Everything, even quantum processes, are ordered processes. And that, to me, is the face of God. You can quantify this. The brilliant mathematician and physicist Roger Penrose tried to do this calculation in which he attempted to derive the probability that a universe like ours would get going with the potential for structure that he has. He came up with this ridiculously small number for that probability. And, people have tried to sort of correct it or fix it, but they still come up with these ridiculously small numbers. And so when I see the cosmos that we live in, and I see the order in it and the beauty of it, there is really the face of God behind it. And Aquinas, St. Thomas Aquinas, is someone that I've begun to read as a person involved in the Thomistic Institute in Washington, D.C., which the Dominicans run. In fact, I was giving a talk yesterday in Berkeley to their chapter. And Aquinas himself recognized that that diversity and order and beauty were linked together, and that was a sign of the divine intellect. And I feel very very privileged and very grateful to be in a field, in a discipline where I get to study that order and beauty in the cosmos every day. But I can't forget as I do that I only have to look at the faces of my friends and colleagues and people I meet on the street to see that there as well.
Is there a moment that comes to mind, a particular instance that was a turning point in one way or another in your life that you can say, oh, this really knocked me off my feet?
In science or in my spiritual?
Either.
Okay. Well, I'll give you one example in science because that's what we're talking about today. I do have a spiritual one, but I'll save that for a smaller group in a personal environment. Sorry for everyone else. Now you're all wondering, gee, what was that? What was that? In the science environment, when Cassini arrived at Saturn, deployed the Huygens probe, which was built by the European Space Agency, a flying saucer designed to fly into the thick atmosphere of Saturn's moon Titan and land on the surface. That took images on the way down, and the camera was built by a colleague of ours, Martin Tomasco, at the University of Arizona. So I was involved in the mission, but not on the camera team. We're all out at the European Space Operations Center in Darmstadt, Germany, in the middle of winter, so it was dark all the time, pretty much. And that's where the data came back. No one had seen the surface of Titan before because it's cloudy and hazy. And here was this probe swinging on a parachute, taking pictures of it. So Marty invited me to be with the imaging team at the moment that they got the data. And they were not in a room in a building. They were in their own trailer in a parking lot in this facility. So we were isolated, 20 of us. The data came down from Huygens to Cassini to the Deep Space Network to the European Space Agency. They just didn't look at the data. They just separated the imaging data out, sent it to us. And there we are, late in the evening, middle of winter, in a trailer in a parking lot. And we were the first eyes to see the surface of this unknown, previously unknown moon, this unknown surface of this moon. And these pictures came through sort of flashes, like kind of like the scene in Clockwork Orange, if you remember. And you could see they're out of order, and you could occasionally see gullies, which were carved into the side of a hill. They weren't gullies carved by water. They had to be carved by liquid methane. And that was the first evidence that liquid methane runs on the surface of Titan, liquid methane, like water on the Earth. So for about an hour and a half, we were the only human beings to see the surface of this world. And it was like being astronauts in an orbiting spaceship, getting data on the planet below us. Nobody else had seen this. And then for the rest of the night, we put this together into mosaic. And this image of this world was sort of Earth-like with the gullies and pebbles and things, but it was also very alien looking. And it made an impression on me that this is a place that humans should explore, but we shouldn't really live there. It's not made for us. The Earth is what's made for us. This is an alien place. That's what kept going through my mind. It looked like a scene out of Dante, to be honest. And so that to me was the most moving scientific experience in my scientific career that I've ever had.
Wow. That's pretty darn spiritual.
It was amazing. It's amazing.
Thank you very, very much for being with us today, Jonathan.
My
and thanks to the class in Knoxville, and thanks to all of you guys who have joined us. See you next full moon.
All right, that's everyone.
See you later, everyone.
Bye, Bob. Thank you.
Later.